So today we're going to be on lesson 3 talking about torque and lever. We already talked about what levers are, right? So basically a point that is turning with a fulcrum. And we're going to talk about this other term that might be new to you. I don't know. You might have heard this before. Torque. Okay, so what is torque? When a force causes an object to rotate, a torque has to be applied. So what the definition for torque is, it is the turning effect. Okay, is usually caused by a force on a rigid object within axis. Okay, the symbol for torque is capital T, and is measured in the units called newtons meter. Right. So everyday examples of torque is, say, opening and closing the door. There's two ways of doing that. An easy way is to push at the doorknob, which is very far from the hinge. And it's a lot harder if you try to push from the hinge. I don't know if you can imagine what they're saying. So if this is a door, and imagine the door has like an automatic shutting device, right? So this is the door handle, and this is the hinge. Okay, the way we open it, we usually put our hand right here, right? And when our hand is there, we can measure the distance from the torque, the spinning. See how this is the rotating part, right? That the hinge is the part that is rotating and opening the door. Versus if I do something like this. If I have a door that is this big, okay, the handle is here, the hinge is here. But if you put your hand somewhere around here, you would find that this would be a lot harder to open the door, and this will be a lot easier. Okay, easier means that you actually would apply a smaller force, versus harder is when you need to apply a bigger force to turn. The torque is the same for the two doors, okay? Because it's the same thing. I'm spinning this, so the torque in this case and the torque in this case, capital T, are the same. Okay? What has changed is the distance between the fulcrum and the hand versus the distance between the fulcrum and the hand. So that means if the distance increases, the force required will be less, and opposite to that. Okay, so conclusion to that is whenever the force increases, your torque would increase. And whenever the distance from the fulcrum increase, the torque would also increase. We use this term called proportional, and you can see it from the next equation. The equation for torque is force times distance. Keep in mind that this distance is always measured from the fulcrum. Please make sure you write this down, okay? Measure from the pivot turning point, the fulcrum, okay? Remember the circle thing that we were talking about? T is F times D, that is the symbol. And we already talked about the unit. So sometimes on the question, even when they don't say torque is 20 Newton meter, but when you see something is measured in Newton meter, you know that they're talking about torque. We already know that from the last unit. Force is measured in Newton, and distance is measured in meters. And here is the magic triangle for it if you would need to use it. So we were to write out the equation. I know that torque is F. So the first equation is, if they ask for torque, it is F times D. If they're asking for F, okay, so if I'm asking for F, T is at the top, D is at the bottom. So T divided by D. If I'm asking for D, then D is what I'm solving for. So D equals, now take a look at what's left. At the top is T and the bottom is F. So from one equation, you can get the other three. So the rest is just being comfortable with solving the equation. Okay, so the key thing that I would really needed you to do is recognize the unit. Okay, calculate the magnitude of torques. They want you to find torque. Torque is your unknown. On a wrench, applying a force of 84 newtons on a 0.25 meters away. Okay, so they asked me to find torque, so T is my question mark. And they tell me the force, meaning capital F, is 84. I still find that some of you don't write your given out properly. what properly means is you would have a symbol, you would have a number, and the unit associated with it, and they should match, right? So if you're unsure, you go back to your study notes, which I would suggest you do, and we had this written out here. So when something is measured in Newton, I know it represents force. You refer back to your chart, okay? And then it tells you in a boat 0.25 meters, so 0.25 meters, that is my distance. Equation for torque is F times D. So I can now just plug it in, 84 Newton times 0.25 meters. Punch it in your calculator. So 84 multiplied by 0.25. I get an answer of 21. This is the part that people are going to be stuck on the quiz. What's the unit for torque? If you're unsure, you go to your study note. That's why you have your study note in front of you. I'm going to look, oh, torque is Newton's meter, and it makes sense, right? I have Newton times meter, so the unit is Newton.